All right. Well, good morning for me, good afternoon, and possibly good evening. My name is Brian Randall, and I'll be your host and presenter for this talk on DevOps for your relational database foundations. Now, a little bit about myself. I've been doing this a long time. I view the world from the standpoint an application without a database isn't very interesting. You'll find my contact information on the slides, and I will post a link to the slides in the Slack channel for track 4 a little later this morning or today. So let's just get right into this and make sure we're level set on the concept of DevOps, right? When we think about what is DevOps, there's lots of different definitions. Wikipedia has one, but I'm really fond of this definition, which comes from Donovan Brown at Microsoft. And we talk about how DevOps is made up of this union of 3 key things: people, process, and products, with an ultimate goal of delivering value to your end users. And so when I work with organizations on DevOps in general or focused on the database, it's always important to understand that the root thing to work on is the way people interact together, so that people and process thing. You can't buy DevOps in a box. It doesn't just magically appear because you use a particular product or set of products. Now, understand that a holistic set of products working together can make the difference in how you do things. In particular, making the decision to buy versus build can be critical in those aspects. As we are in 2021, we're very lucky in that we have a rich set of tools available to us, both that are available from commercial vendors, but also from the open source community, to where you should always be able to find something that can help you with your DevOps transformation and journey without necessarily having to build your own tools. Building your own tools is often the siren song that developers get into, and it can often be a mistake. And in the case of database DevOps, I've seen a lot of that over my career. When you think about DevOps, it's key to understand that it's a journey, not a destination. In fact, DevOps tends to follow a J curve. When people first get started with it, they're really excited, you get some quick wins. And then there's that slog as you try and get to the more far-reaching problems that are both organizational and technical. So the thing I'll encourage you is just to always keep this in the back of your mind, right? Sometimes you'll go faster, sometimes you'll go slower, but it's a continual process of improvement. Now, at this point right there, there's a lot more I could talk about DevOps concepts and precepts, but this is more of a tactical presentation. So I'm going to assume that you understand that you got to work on the people and process, right? We often say that, DevOps is that second decade of Agile. And so Agile processes scale to organizations is where it gets very complex. But one of the things we need to do then is we know that tools come last, but a technological win can help really kick off the journey. One of the things I do working with Microsoft and GitHub as a partner is I go to companies and do an engagement called a fast track. And as part of that fast track engagement, we try and pick something that's a combination of technical and process to improve over 2 weeks. And our goal is to show how that type of smaller win can have a bigger impact on the organization. So in this talk, we're going to do just that and talk about how we can have an end-to-end process for our database that we might already have for our source code: C#, Java, PHP, Go, whatever. And what we want to do is set up an end-to-end pipeline that allows developers that are focused on databases to check in their changes to source control and have the same workflow we've hopefully already been doing for 10, 15 years in our organizations, where we do continuous integration, which at a minimum is a process where we go through and validate the input from the developer with other developers and go for that. The simplest of things, does it compile? Beyond that, hopefully we're embracing other things like running unit tests. And then once we have the output of the build, we can use some type of release management technology to then take the database and deploy it to shared dev environments, local devs, testing, and ultimately, possibly production, all with an automated end-to-end pipeline. Now, databases are a funny thing because not only do we have this definition of the structure, the catalog, we have data in there. So databases introduce their own complexity in this process. But the biggest mistake that I see out there is a bunch of developers working on a shared database, just making changes without any process and without version control. And then relying upon either homegrown tools or the very basic of available tools to get the changes from that shared dev environment into their various production environments. So we want to do this how? Well, we're going to look at this using changes to a database through an end-to-end pipeline. And we're going to start with that inner loop of just the developer, and then we'll move out to the larger scale pipeline. Now, I'm going to use the SQL Server data tools that come inside Visual Studio 2019. The acronym is SSDT that you'll hear used, and we use Azure DevOps pipelines. Understand, though, that there are other tools available, and the basic concepts apply to all relational databases. It just might vary based upon the tools you use to actually get the mechanics down. For example, Redgate has a number of commercial tools available for both SQL Server, and with their acquisition of Flyway, they're actually supporting a lot of other vendors, including Oracle, for example. Octopus Deploy is a rich set of tools for doing deployments. GitHub has GitHub Actions. So understand that while I am going to use the Microsoft tool set with SQL Server and Azure DevOps, you can mix and match as you see fit. But going back to that diagram, the same concept's going to apply. We want to version control our database. We want to have some kind of build validation process, and we want to use automated deployments to have a repeatable process to get our changes out into our various environments. Now, when coming up with tools and technologies to do this, there's kind of two approaches. One is the model approach. And this is what SSDT takes. The idea is that we're going to take the catalog or the definition of the database offline and use a state model. We're going to express that model in the form of DDL entities. And that's what we're going to work with. So rather than using, say, a graphical tool to manage the changes to a table, we can do that with create table statements. And by breaking down our database into this set of DDL files, we have these individual entities that we can then check in and check out of version control, whether it be something like SVN, TFVC, or what I'm going to use, Git. Now, the way SSDT works is you have a project inside Visual Studio with all of these files organized as you see fit. And then you publish your changes by comparing that model to your target. If the target doesn't have the database at all, then it has to create everything. On the other hand, if it sees that there are existing objects, it will go through and build an in-memory diff of the target and the model to figure out what changes need to happen. This is sometimes referred to as this golden schema approach. We want to take our definition of the model and apply it to the database. Now, from a mechanical standpoint, this can be done with what are called DAG-pack files, or you can actually generate SQL scripts, and I'll turn on both so you can see that. The idea with models and the database is that you're expressing what the database should be, and we're using the tools to get it forward. Another approach, however, is known as migrations. In the .NET world, EF Core is an example of what this is, and other ORMs or object relational mappers do this. The idea is that we're going to express via SQL migration files that are played back in a sequence. And basically, we're able to walk up, look at the database, and there's usually some type of version table that says the database is at this migration. And the system will say, okay, I've got 10 possible migrations. The database is at 5. So I'm going to play back migration 6, then 7, then 8, 9, 10, until I get it to the level you want. The whole point here is we're migrating changes from the model in a stepwise basis. Now, this is different from the model approach in that it expresses how your database should change, and it provides a more logical view. Neither mechanism is better than the other. They all have their pros and cons, and success with both is often your comfort with the tool set and how you change your database. But another thing that affects it is the considerations I want to bring up. And this is probably one of the key takeaways, because this is where the devil in the details exists with database DevOps. The first thing to understand is this notion of people and process and getting everybody on the same page. One of the most common aspects you'll run into is drift between your offline model that you're managing in version control and the target of the change. This particularly will run into when you have separate teams that work on applications and the database versus a team that is responsible for managing or maintaining that database. DBAs sometimes are reticent to allow automation into the database. They're responsible for keeping the database safe, protecting not only the structure, but the data. In addition, they may be responsible for actively managing the database while it's online. And so we have to take into consideration that drift where what we think the database should look like when we go to apply the changes, someone's made a change using some other tooling and we're not in sync. And once again, that often happens when you have a demarcation line between dev and production that you don't really communicate well with, or it's a more traditional siloed approach. And so that goes back to that whole people and process thing. The secondary aspect that you have to be aware of is multiple apps using the same database where we need to coordinate changes between them. One of the things that I've seen success with for teams that are trying to use a DevOps process, use an automated pipeline, is to create a V team around the database changes and manage those independently of the application. So that when someone needs a change, they have to have this in the database, it's brought to the V team, the change is made there, and then the application is able to pick it up. This prevents a lot of chaos that occurs in changing this foundational structure. That also introduces a little subtlety in how you manage your database. As I mentioned, we have this notion of this offline catalog or definition of the database that's expressed with SQL statements. But there's also a subtlety in the two types of things there are. There are the objects that define what we're storing data in. For example, tables, things that we use to look at the data, the views. And then we have programmable objects like stored procedures, table value functions, etc. You can bifurcate your management of those as well, to where you allow developers to work with a project that is just that subset. You can do that with SSDT, you can use it with the Redgate tools, for example. And so all these things require you to communicate and work out a plan. And this is independent of the tools, right? The tools will drive some of the decision-making and actual mechanical implementation, but you have to coordinate. This is where people have to talk. Now, one thing that people want to be able to do is update the app and the database together. And this can be done very easily with the tools I'm going to show you in simple cases. But as you get to large-scale online 24/7 applications, it gets complicated. And so you'll often have to come up with a plan where your application is resilient against different versions of the database. The common approach here is that we implement some type of versioning table and the application can check where it's at. In doing this, you also have to think about updating the database and making sure it's stable before you go forward. And this is going back to that notion that the database isn't just code, it's code structure and ultimately that data. And so with a lot of successful teams that I've worked with, the idea is that we get the database update out there. The app continues to run against the new version of the database. It just ignores new fields and new values. And then we update the app. Now, once again, this gets very complex. And ultimately what I'll tell you this is if you can have an outage window to update your database, take it. Doing online updates with concurrent access to the system is much more complex. It's doable, but it really increases the complexity. So don't do it unless you actually have to. Now, regardless of whether you use a model-based approach or a migration-based approach, one of the things you have to consider is data motion. And data motion is the process of dealing with structural changes of where the data is stored or how it's stored. A common example is to split up a field where you haven't maybe normalized it correctly and decide later that a field that contains two pieces of data, and a common example is you have a full name field and realize you want a first name and surname field. That type of operation is not usually magically happen by any of the tools that I know of. In fact, this is the hardest problem. So what you often have to do is think about pre and post processing that occurs as you make that type of change. SSDT, for example, supports pre and post processing scripts. And one of the things that people often do is, naturally you do a full backup before you started the operations, but then you migrate some of the data into a temporary table, change the table, and then migrate the data back as a secondary step. This is not done automatically. It requires you to use your brain. And that's probably the big thing about using these type of tools. They're not going to replace you or me. The reality is that these are complex problems that need to have people that understand the structure of the database and how the data works together. Another issue is static data loading. Lots of databases have the standard business logic data, but then they have supporting lookup values, everything from postal codes to geography information to product codes that may not change as much on a regular basis, as an example, so lookup data. That type of static data loading might be necessary as part of the process of doing a large-scale transformation on the database. And again, you can package those with your model, or you can do it as a secondary step. And the last thing that really needs to be considered is we get into testing the changes to our database in having good compliant test data. One of the mistakes that I'll see a lot is developers are given access to data out of production. And if you work in a regulated industry, such as the financial sector or healthcare sector, you really put yourself and the organization in legal jeopardy by using production data that hasn't been properly made compliant for developers to work with it. So you'll want to look at this. And this is one of those areas where there are tools that are available. Some are quite expensive, or you can kind of bring your own tools to bear. The key is that you don't want developers just taking random backups of the production database. Now, related to compliant test data is actually testing the database. And there are tools out there that will let you do testing. T-SQL-T is an example that Redgate supports with their SQL test product. T-SQL-T is open source and available for free. The reality that I found with doing database unit testing is that it often sounds good to everybody, but the reality is that it falls by the wayside. And so what I tend to find works more effectively, because people actually do it, is they wrap up their database testing as part of more functional testing of an application plus the database. I'm not saying if you can do database unit testing, more power to you. You could do that during the build, but the reality is that doing it well requires a lot of discipline. And in my experience over the last 10, 15 years of working with this, I don't see a lot of it. People just find the complexity of doing it right is hard. And part of that also goes back to that compliance on the test data. So keep all of that in mind when you think about this part of your journey. All right, I'm done talking. So let's do some demos. So what we're going to do here is we'll start with that inner loop, and I'm going to show you how we put a database under version control using SSDT. I'm going to use Git repos, and I'm using Azure DevOps. As I mentioned, a lot of the tools that I'm using here can be mixed and matched to give you that end-to-end pipeline experience. You just have to figure out what works for you. And then we'll see about creating an automated CI CD deployment pipeline. So let's jump out of PowerPoint. All right. Okay. So over here, I have a local installation of SQL Server 2019 or SQL Server 2019. I'm on the latest with CU8. There's a GDR that came out a couple of weeks ago. And so we're good to go there. If we look at my database list, I've installed a few sample databases, 2 different versions of AdventureWorks, and then some Blast for the Past here, some Northwind, and Worldwide Importers. And the thing that I'm just going to show you is that we'll probably just start with Northwind, is that SSDT works with very simple databases and works with very large databases. It really is just a matter of figuring out what you want to do. And understand that when you start to use it, you can start from an existing database, or you can start with just a raw SSDT project. So if we come over here to Visual Studio, we come over here and say File, New Project. And when the project list loads up, you'll see that they've added a filter mechanism here. And what you're looking for here is query language and the SQL Server database project. Okay, so I've got this set to all platforms, all projects, but most notably, I'm filtering down to query language. Now, in order to get this installed, you just need to install any version of Visual Studio, so Community, Professional, or Enterprise. And you just need to make sure you pick up the database workload. That installs the SSDT tools. As a point of reference, a lot of you may know that SQL Server has its core relational engine features, which is what we're focused on here today, but they have other areas like SSIS, the analysis services, reporting services. Those projects and those features are not included in this experience. We're focused on just the relational database and its programmable objects. There are additional tools for working with those project types for Visual Studio. However, they don't get installed with the 2019 database workload. If you want to get those, you need to get them from the Visual Studio Marketplace, which you can access from within Visual Studio or by going up to the Visual Studio Marketplace website. So I'm going to pick a SQL Server database project, and then it's going to want a name. So we'll just call this NWind. Let's do NWind NDC. And I keep my code over here, and I've already got a local repo set up, so I'm just going to grab this path here, and we'll paste that in, and I'll create a new subfolder called SRC, and I'll hit create. And after a couple seconds, you're going to be super grateful you attended this talk because you'll see this amazing bit of technology. Sarcasm should be noted, right? Because when they actually get done, you end up with this empty shell of a project. And part of that may be pretty obvious, right? It didn't know what database. I said NWind, but it doesn't, that's not a database that exists anywhere. And that means we have to do a couple extra steps. If we right click on the project, there's an import option. And that import option shows 3 things you can choose from. One, you can use a DAC pack. Now, a DAC pack is basically a zip file for all intents and purposes. And it complies with the open packaging format, I think it's what it's called. But at the end of the day, it's a zip file that contains an XML model that expresses what the database should look like. And as I mentioned, this is going to be an output option from our SSDT project. You'll note that there's also an option here to get a hold of the database. And then finally, there's an option to say, you know what, I want to use a script. We're going to use the middle option, which is let's import from a live database. Naturally, the other options work well when, for example, as a developer, you don't have access to the target you want to work with. And so you have a DBA or a customer export the definition for you using their tools. So we'll select database, and then we come over here and say select connection. And we can show connection properties here and go through and pick. I've already connected to Northwind and done some tests. If you don't like something on the list, you can remove it from your history. But you'll see there's Northwind and Worldwide Importers. And as you'd expect, you fill in the dialog per normal connecting to SQL Server. So I say connect, and then you'll see I have some options. For example, How do I want the folder structure set? Do I want everything as just one giant flat list? Or do I want it organized by schema? And this is ANSI schema, so DBO, application, etc. Or do you want it just by object type, so table, view, etc. How many files per folder? Obviously, technology has improved over the years. When Microsoft first set this up and came out with SSDT, it was back all the way in 2008. It released as an add-on to Visual Studio 2008. A lot of people still use spinning Rust. So if you have an SSD that you're working with, faster systems, you can probably increase that number if you'd like. But the bottom line is they typically keep it around 1,000. You can control additional settings you want imported, but we'll just start with the basics. And so what it's walking, the database catalog, it goes up and says, tell me about yourself. And then it extracts or shreds all of the objects in the database into those DDL files that I mentioned. So there's all the tables. We can see some stored procedures. And we can see that there are even some views available. Each of these items is something that I can then double click on, and then I'll get an editing experience. In the case of the stored procedure, it's just a T-SQL editor. However, in the case of a table, if I go look at categories, not only do I get a text-based view, which I can control and swap here, I also have the ability to use the graphical designer to both design and update my definition. But this provides just that foundation of, let me get a snapshot of what the database looks like offline. Now, naturally, the thing to remember that this is just a definition of the structure, right? We don't get any of the data that exists inside here. So if I say select, right? So there's 8 categories there. But we'll see that we do have tools to help us with this if we want. Now, at this point, a common thing people say is, okay, great, I've got this. How do I then set up a test environment so I can mess with it and see how it looks in SSMS? Well, if you right-click on the project, you'll note that there is a publish option. And when you use to publish it, it lets you control the various settings of where you want to publish it, what do you want to call it, etc., and whether you want to register it as a data to your application. Before I do that, though, you'll note that there is a properties node here. If we go to properties, there's a couple important settings. One is the target platform, and this shows you which versions of SQL Server that this version of SSDT supports. And you notice it goes back actually pretty far to products that aren't even in support anymore. It, for whatever reason, defaults to 2016. However, I'm going to be working with 2019, so I'm going to change that compatibility level. You'll note also, though, that they have settings that are available for working with Azure and Azure Data Warehouse. So it's important that you set the target platform before you get too busy with what you're doing. In addition, there's an extra setting here that says, when I do a build, and that build is the process of going through all of those DDL files and generating that model, would you also like a .SQL file that you can give to a DBA? And this is what I often refer to as that peace offering to really get the DBAs in your organization to buy into this. Have them work with you, show them, right? Some of them aren't going to be very interested in using this Visual Studio tool set. They might have a way of doing things, and we want to respect their position, right? That they're trying to protect the database and often the organization so there's no data loss, et cetera. So we need to work together, and by having the SQL script, we can do some of that. So there's other project settings in here, including the ability to have code analysis, so that when you go through and generate your model, it will look at the T-SQL that you're using to express your DDL, as well as your things like your programmable objects, and you can do that. There's some settings here for SQL command variables that you can use in your pre and post processing scripts. And there's even some stuff related to SQL CLR, although honestly, I don't see a lot of people using that anymore. It was an interesting thing in 2005 and never really took significant hold in my world. So once we've set that up, we can now right-click, and when you go to do a publish, that implicitly is going to do a build. And that's going to go through and validate that you don't have any SQL errors. And then it's also going to run the code analysis rules if you've told it to. Now, I can go over here and do a target connection, and I can pick Northwind, but that's the database I already have. So what I'm going to do is change the name to Northwind-dev. I'm going to click OK. That's going to update the database name here. It's going to create a SQL script that matches the name of my project, and I can hit publish. So as we see down here, we have a data tools operations, and it shows us that it went through, created the publishing preview, built the database script, and then executed it against my local instance. So if we right-click on my database node, refresh, we now see I have a Northwind database, and we see all the tables, views, etc. Now, let's go see what happened when I did that compile. If I right-click on the project setting, I can go look at that folder in the File Explorer. And if we drill down, there's a bin folder and debug. And so this matches your standard configuration types in Visual Studio, debug versus release. And you'll see that it created a deployment report, a DAC pack, a DLL and PDB, and those are mostly side effects. Please go away. Go away. I'm not pausing, thank you. And it paused. I don't want to pause. Resume. There we go. Sorry about that. WebEx decided to get involved in my presentation. If we go back into the folder, there's the supporting files, and you'll notice that there is a create statement as well as the publish statement. And so if we take a look at this, for example, in Visual Studio Code, and make this a little larger for you, right? You can say this code was generated by the tools. You make changes. It'll obviously screw it up, so you're not going to do that. Notice, for example, it specifies where it's going to create those files. It's going to pick those up by default from your SQL Server installation. You can, of course, change these variables. And you go through, and it shows you the SQL that it will use to create the database. Now, it's able to figure this out because it goes to the system and says, okay, what do you have? Well, this database doesn't exist, so I'm going to create a richer script. Now, let's go look at this DAC pack. And as I mentioned, it's basically a zip file. So if I rename it to .zip, I can then open it up, and you'll notice that there's this model.xml file. And so if we look at that in Visual Studio Code, you'll see that this is what the tooling uses as part of its comparison and creation. So when you go to do a deployment to an existing database, it says, okay, there's a database here. So I'm going to load what I think the database should look like. And then I'm going to go and talk to the database just like it does when we reverse engineer the database. And then it's going to create a diffgram in memory between the model that it wants it to be and what the database looks like. It will, by default, block changes where it can't guarantee safe changes. So, for example, narrowing conversions of a column, changing the size of an varchar column, for example. Those type of changes are destructive possibly to data, and therefore those will block by default. But as you can see here, we have all this XML describing the various items, and then deep down inside here, it's hiding all of the actual T-SQL that is used for the database. Okay, so we've seen it work locally. Now let's actually get it into version control. Now, as I mentioned, I've already got a Git repo. And so if we come out here, it says, hey, it looks like you made some changes. So we're going to come over here to the Changes tab, and we're going to enter a message. I'm going to say add base Northwind database via SSDT. Now, one of the great things about Azure DevOps is it provides a nice holistic set of tools for storing our code. We have repos, but also lets me track my work and then deploy my work with pipelines. If I go to boards, I can see work that I'm tracking and basically provide a justification for what I'm doing. So I already set this up, and let's easy to get started. You can get your own free account by just going to dev.azure.com. And I have a demo for SSDT. So this is a work guide that lets me track what I'm doing. I always want to keep a link to any commit to a work item because the work item gives me the business reason I'm doing it, whereas the code represents the thing I'm changing. So this is work item 374. So I'll come over here and I'll click the plus sign, type 374. And this will just basically give me traceability. I don't know about you, but I can only keep so much in my head. And so by having this information, and we'll see this will flow all the way through the pipeline, I'll be able to know who made the change and when they changed it and why. Then we see all of our changes here. So I'm going to include those. And we'll commit. And then we're going to push our changes up to Azure DevOps. So we'll give it a second to finish that. Now if we come over back to my web browser, go over to repos, go to history, and we can see adding our files in here, and it'll show what the file looks like. And the great thing is over time, we can see things, how they relate as they're diff. For example, I have a README file that I updated earlier. If I click preview, since it's marked down, I can see it, but I can also see its history and I can compare the two changes. So you get this all really nice experience inside your browser. Okay, we've got our model in version control. That was step one. Step two is we want to be able to compile it. Now, once again, this is where you'll have to look at the scope of your database. Does it work with other applications? You can build it as part of a larger solution. In fact, this is just a regular Visual Studio solution. Nothing stops me from coming over here and saying add new project and coming over here and adding, for example, a WinForms app, a class library, whatever I need to do. That's completely up to you and how you want to manage the process. Like I said, it works well for smaller departmental apps or a very cohesive app and database, particularly if you're lucky enough to do a file new. But when I encounter people working with databases and wanting to bring database DevOps into their org, they've often have a database that's been around for a while. So we typically find that managing it independently works more effectively for an organization, particularly as they're doing their initial journey. So what I'm gonna do is go over here to pipelines, and pipelines lets us do two things. It lets us build, but also lets us release. Microsoft supports two generations of pipeline. They have the pre-existing mechanism, which I'm going to show you, which I find still a bit richer and easier to teach off of. They, however, have a newer model that is quite popular with a lot of different products in the industry that's based upon a text-based definition called YAML. Microsoft does this with Azure DevOps now. It's also available in GitHub, and other third-party products do it as well. The idea is that we express what we want our build and release to be as a text file that's then checked into our repo. There's some advantages to that, but I find looking at a wall of text is not a great tooling experience. So I tend to use the visual tools when I'm teaching. So we'll do a create pipeline, and we're going to come down here and we're going to pick the classic editor. I guess I'm a classic rock kind of guy there. And you'll notice it says, well, what's your source? And you'll notice there's a lot of different choices here, but we're going to use Azure repos based on Git in this existing team project. So we'll just hit continue. And now the issue is, well, what do you want to build? And you'll note that there's a bunch of choices here, templates. Unfortunately, if I type database, there isn't one I want. I'm going to just pick .NET Desktop and hit apply. Now, what it is showing you here is a couple of things. Number one is you're going to have a pipeline that's going to execute. And that pipeline is going to get its source or input from somewhere. In this case, the Azure repo that I've pointed to. Then it's going to use an agent to actually execute and do the processing. Microsoft provides hosted agents for Windows, Mac OS, and Linux in the cloud. And they give you a certain amount of free execution time on those hosted agents. If you need more time, you have a choice of purchasing that from Microsoft, or you can install a local agent in your environment, whether it be on a server or, believe it or not, even on your local desktop. And that's what I've got going on here. Once I get the build running, I'll show you what that looks like. In either case, you control the agent information by default at the pipeline level. However, it is possible to have additional agent jobs. So let's say you're building native code for both Windows, macOS, and Linux. You could actually set up your pipeline to fan out and do all three on different agents at the same time. But I only need one, and so I'm going to come over here and change the dropdown from Azure Pipelines, which is the hosting experience, right, the version that's up in Microsoft's cloud, and instead I'm going to pick private. And the private pool is one that I configured. And as I said, I'll show you that in a second. The next thing it will do here is at the pipeline level, different templates can provide variables that apply to the entire pipeline. And so one of those is going to be the solutions. So we're going to come over here, we're going to grab that. And then you'll note that that variable then linked down automatically to the build settings here. Now, I'm not going to use these NuGet settings because I don't have any C# code or anything I'm using. So I can disable them, or I can even delete them. I'm also not going to run any tests right now or publish symbols, so I'll disable them. So I'm going to make this a very simple pipeline. Now, in the case of the build, I'm going to tell it just to use the latest version, which is on my machine, but you can pick a particular version if you need it. Finally, you can provide customized MS build arguments, as well as use various variables which are available here, such as the configuration you're building, the build platform, etc. Finally, when it's done, I want to get the interesting output from the build and make it available to users who want to download and look at it. But more importantly, I want to make it available to my deployment pipeline. Now, by default, it's going to copy everything, and that's a little too much. What I want to do instead is say, you know what? Go get files out of the bin folder for this build configuration, but what I really care about is the DACPack file, any .SQL files, and then finally a publish.xml file. So when I went and did the publish, I right-clicked and published manually, and you can set different settings in there. Some teams like to use those XML configuration files to fine-tune the way the deployment works. So if you generate an XML file, you can include that from your build and into the release, and you can pass that as part of the release process. I'm just going to do this for completeness, even though I'm not using one in my example. Now, once I copy the files, it's going to put it in a staging directory on my agent. So then I need to get it off the agent, though, because right now the agent happens to be on my machine. If you use an agent in the cloud, you're only getting that agent for the time it takes to run your build. It's not a place you can go back and get to later. So it's your responsibility to take anything that is on the agent that you find interesting after a build, and you need to copy it into some storage location. By default, Azure DevOps provides storage as part of Azure Pipelines, and so we'll just put it up there in a slot we call drop. Now, one of the things that will happen by default is when we copy those files, it will include the file tree of where it found the files. If we go to advanced, oh, sorry, it's on the copy file, sorry, under advanced, there we go. We can flatten folders. And this is put everything in one folder, make it easy to find. Now up here, I'm going to change this name, and we'll say, what I call this, NDC build. Okay, so I'm going to save and queue. It's going to run against my private agent, and it's going to run. We'll give it a second. So it gives this nice summary about what's going on here, and then it kicks off an agent job. You can turn on diagnostic and actually watch the spew down here, but right now it's just going to say it's running the job. And so we'll come back over to our web browser. And one advantage of also running locally is it runs faster because my machine's already booted up and ready to go. And that's it. It took us, what, about 10 seconds to run. Not bad at all. Now, the key thing is it shows you the commit it was linked to, the branch, what repo. It shows you the work items that were linked up. So remember when I did the commit, I linked up that one work item. So demo SSDT shows it's in progress. And most important though is if we go to the artifacts, it's showing me that there is a drop artifact. And inside that, this is a DAC pack and the create SQL script. So now I've got a build. Now, one extra thing I might want to do then is make this build run every time someone pushes. And you have lots of control over how you do this. You can do it by branch. You can have branch policies. You can prevent people from doing it into master like I did. But what we're going to do here is we're going to click on triggers, and we're going to say enable continuous integration. And we're going to say build every time someone pushes to this branch. So we'll save this, and instead of saving queue, I'll just say save, and we'll leave a comment, enable CI. Now, the nice thing is that even though these aren't readily editable, Microsoft does store this file as a text-based representation. It just happens to be a JSON file. And so you can compare your differences here, see what the changes are. And there are APIs that let you import and export these if you want to move them between systems or do customized tooling, which I discourage, but if you need it, you do it. Okay, so now I've got a build that builds my DAC pack. Now I want to be able to release it. So we'll say new pipeline. And again, it'd be nice if we had a template, but we don't. So we're just going to say empty job. And we're going to call this shared dev for the stage. Now, what's going to happen is going to say, okay, you can bring any number of input artifacts into your release pipeline. So you click add an artifact, and you can pull stuff directly from repos. You can pull it from file shares. You can pull it from Jenkins, Docker, etc., even Azure artifacts. But we're going to use a build, and when we use the build, we're going to use the output of that NDC build. It's going to let us specify the version we want, and we're going to always take the latest in this example. And you can provide a source alias, which by default is take the name of your build and throw an underscore in front of it. Once again, whatever works for you. So now I'm going to say that take input from this build and make it available to this pipeline. And one of the great things about Azure DevOps pipelines is that we have full control of how something moves through the pipeline. We can have pre-deployment and post-deployment conditions. And you'll notice that they have little people heads, which means we can involve the humans in our process. So we can have someone validate something before it goes from one place to the other. Now, you'll notice it says one job with 0 tasks. Well, we need to do something. So we're going to come in here to the job, and you'll see it has a similar setup to the build pipeline. In other words, it's going to have input, in this case, artifacts instead of the version control, but it's still going to have an agent. And so we're now going to add a task to our list here. And we're going to come over here, and we're going to search for database. And you'll note that there's a couple choices here. Note that the DAC pack that I'm using, I could deploy both locally and to Azure, but I would use a different task if I was using Azure. You notice there's also other tasks for working with MySQL and other databases. You'll see I have Redgate SQL automation installed, etc. So we'll pick SQL Server Database Deploy. And now we got to come in here and set up our options. The first thing is, where's this DAC pack file? Well, that DAC pack file is part of that input from my build. Note, though, that I also could specify a SQL query file as well as inline SQL. You can stack multiple database tasks if you needed to do your backup, your data motion, or anything else you need to do. So even though I'm just using one, you're not limited to just one database task. So I'll come over here to the browse, and this is going to let me drill down into that drop output just like I showed you from the build. So we'll click OK. Now, specify the server that we're going to use, and we have the server name here. Now, it's not localhost. Now, I could type my machine name. The problem is if I want to have other stages and everything else, I might want to change that. So we have the ability to have what are called pipeline variables. And so I could have something like server, and we'll call this Raven because that's my machine, and I can verify by looking there because I'm forgetful. And then I have an instance in this case, and so we'll copy this as SQL 19. Now you can scope these to the release, or you can do it to a stage. So I'm going to mark them for release right now, go back to my tasks, and then to use that, I simply do $ open paren server close $ instance. If there wasn't an instance, it would just be a blank string and I'd be good to go. And now it's the database name. So we'll do, let's see, we call the other one Northwind Dev. So we'll do Northwind Shared Dev. I'm going to use Windows authentication. You could use standard authentication if you had to. And if you had to do that, you needed a password. You could store that in something like Key Vault or some other secure store. Pipelines, though, do let you store what are called secure variables. And so you could actually protect it inside Azure DevOps if you needed to. But I don't need to do that. And then note, here's where you can specify that publish profile file, that XML file, if you needed it, or the DAC publishing process, which is called SQL Publish, accepts command line arguments. All right, so we're good to go. Let's give this a name, and we'll say publish database. We'll save it. Click OK, create the release. And let's cancel for a second because I didn't double check which agent I'm using. So let's go over here to shared dev, agent, nope. So we're gonna use my local one because it'll be faster. So we'll change this to private. And we're gonna come over here and save this. And just like the build definition, this is stored as JSON and it is history, it is versioned and you have the history to look at. We'll click OK. And now we'll create a release. And we'll run it. And just like before, if we come over here, we'll see that it's running the job. You can see logs as it runs in real time. It's deploying the DAC pack. It's done. And the proof in the pudding will be as when we come over here to refresh our databases, we now have a copy of shared dev. So now let's take this one step further, go back to our pipeline. Let's go edit it and let's turn on continuous deployment. So now what will happen is we are going to enable this. And what will happen is if the build completes successfully, which is why we really want unit tests, it'll automatically run and deploy into shared dev. What we're going to do over here is we're going to clone this and we're going to change this name to test. And then I'll come in here to the job. My variables are here, and I can just change this to test. So we're going to say enable CD and add test stage. Click OK. But we'll do one more thing in that here, we're going to add a approval. So we'll come down here, pre-deployment approval, and we'll just say myself. You can restrict who can do it. You can also say the user who's asking for release can approve it. Lots of options here. You can also have quality gates where you let it bake for a little bit. You run automated analysis. You look for errors, etc. Lots of flexibility in the pre and post deployment. So we'll save this. Click OK. And now let's come over here to our project. Let's find one of our tables and let's go to our customer table. So let's open this up and let's add a new field, is VIP. And we'll make this a bit field. You'll see it's showing you the change here. We'll save the change. Come over here to changes here. Now we get full version control diffing. We'll say update customer table. We'll add that related work item, which I believe was 378. We'll see if that works. Nope, that wasn't it. Come over here. New tab, 374. So we'll do 374. It'll give us our traceability. stage our change, commit staged, and now let's push it up. So what'll happen here is when this push is done, we'll come back over here to our pipelines, and we should see right away, there comes our build, which will build that package. And remember, it's just going to build that view of what we think the database should look like. It won't be until we do the release when it says, does the database exist, that will automatically apply the diffgram. Now, by the way, you can see the diffing technology right within Visual Studio by going over here to your tools menu, SQL Server, and do new schema comparison. And this allows you to compare your project or two databases to each other. So for example, I can compare it to Northwind, which I haven't touched. And this is actually what happens all in memory. So it's going to go through and compare. And what it's told me is that there's a change between these two tables, and it gives you the SQL-based representation of what that looks like. So if we go back to my pipeline, looks like it succeeded. Let's go to my releases. And notice shared dev is done. So let's go look at that and make sure we're happy with it. So let's refresh, expand our tables, go look at our customers, and there's my is VIP field. Now, more importantly, if I come over here and refresh the databases, I still have only shared dev because I have not approved this step yet. So if I come over here and click this release, it's going to say someone needs to approve it. And right now it says I need to approve it. I can do that. I can also cancel the deployment and abort it. But I'm going to approve and say dev looks good. You can also say do it, but do it later tonight, for example. But I'm going to do it right now. So it's going to kick that off. And it's downloading, doing the deployment. And now if we go back over to SSDT, do a refresh, I now have a test database. All the tables are there, and I have my table with the bit field right there. So remember, lots of other things going on. One way you can get sample data into your databases is you can maintain a database with that data, and you can load it with scripts, or you can even use the tools inside Visual Studio to do a data comparison. And you can say, okay, I want to bring data from Northwind into one of my other databases, like Northwind Dev, and it will go and look for data, and you can move that over. So there's those tools in here. There's also refactoring tools. If you need to run those scripts before and after a run is done, you simply come over to the solution. There's an option to add your scripts, and you can add pre and post deployment scripts. Okay, so that's where those are. All right, I am down to, looks like 2 minutes. So I will finish up my presentation by saying thank you for attending NDC London. I know this whole pandemic thing has got us in a different mode. I really appreciate you taking the time to come and visit this. And then if you want to get a hold of me, you can post in the Slack channel today and tomorrow. I'll be taking a look there. But in the future, you can get a hold of me via Twitter at Brian Randell, my blog, email address, and occasional podcast, DevOps.fm. So we have a minute. If you have any quick questions, feel free to post it in the chat. But probably it's a better thing to just post it over in Slack or reach out to me on Twitter. So again, thank you so much for attending NDC London and my talk. My name is Brian Randell. I hope you had a good time and learned something. Take care, everybody.